You give people too much option, you give them too much control, and they can get so confused that they end up with a worse result.
Accurate boost control is absolutely critical with any turbocharged car. And traditionally, electronic aftermarket boost controllers were a very, very common option. These days, with aftermarket ECUs being so common, these have maybe fallen a little bit from grace. But we're here with Matt from Turbosmart to talk about the new eBoost 3 and the use case for this unit. So Matt, let's start with that use case. As I just mentioned, obviously now aftermarket ECUs all have some level of boost control, but there are other areas where maybe you need another option. What are those?
Well, I mean, first thing first, not every car has an aftermarket ECU. If you think about your own vehicle, you've modified it. The aftermarket ECU, and this is something I know intimately well, is not the first thing you do when you modify it. Fair way down the modification pathway. So boost controller, on the other hand, you've got a turbocharged vehicle, being able to throw some additional boost at it is going to give you more power straight away. So I think primarily, first and foremost, you do have your OEM vehicles that don't yet have an aftermarket ECU or haven't got enough mods to bother going down that path, or it's maybe too complex of integration. You know, more modern vehicles have a really complex vehicle integration, so you're just flash tuning the ECU for the fuel and the ignition rather than doing a full install of an aftermarket ECU. So in that case, you still want to do boost control, and something like the eBoost 3 is going to fit right into that application.
Let's just roll back to that a little bit, and we'll go into a bit more detail. So as you mentioned, late model vehicles, it's getting difficult, sometimes impossible to run an aftermarket standalone ECU. So yes, if you've got a factory turbocharged vehicle and you can reflash the ECU, you can probably most likely modify the boost targets, but you're going to be stuck essentially with the boost control logic in most instances of the factory ECU. Also, there are instances where you'll have a naturally aspirated vehicle and you're adding turbochargers to the vehicle, so then you may not have that control logic at all. So that's where one of the use cases for this.
Yeah, that's it. And there's plenty of applications where you find either the aftermarket ECU is run out of outputs, or you don't want to do boost control using the aftermarket ECU for whatever reason. You've done an engine swap, or there's plenty of reasons, or maybe it's just doesn't do a great job. Maybe it's only got open loop boost control. I think there's still plenty of applications where a standalone boost controller is going to be functional. And the other thing you've got is real-time programmability, and you can also change your boost settings. So yeah, a lot of aftermarket ECUs will have boost control, but do they allow you to change your boost on the fly? Do they have multiple boost settings? Can you scroll through? Can you see from the ECU? I mean, you can't look into the box of your ECU and see what the boost is running. So a lot of ECUs don't have a gauge. So obviously the eBoost 3, you've got a full display gauge in there. You can see what the boost is doing. You can see RPM. You can make changes to your boost on the fly in the cabin. So all of your changes to boost control, all of your setup is actually done through the intuitive rotating bezel on the screen. So it's got rotating bezel, click bezel. You basically rotate your way through the menu, click the bezel, go into the menu, click the bezel, make your changes, hold it down, long click, move you back through the menu structure. So it's super user friendly. You can do it with gloves, so it's not touchscreen. You can actually, it's got indents on that bezel. You can feel it. It's got feedback there. So it allows you to actually make your changes without, you're like with touchscreen, sort of, I moved on the screen or whatever. That can be difficult, especially if you're in a car that's got a harness, or if you're moving, your passenger might be making changes. Being able to actually have real-time feedback from the actual rotating dial itself is something that's we found pretty important. We actually, when we were developing the product, we had a touchscreen on there and found it's quite unusable in the real world, even on the dyno, on a rolling dyno where you're not on the road or anything, but if the wheels are moving, you do get a little bit of movement. They're just trying to locate where you are on the screen on such a small screen is really difficult. So being able to rotate the bezel, press the thing, double click, long hold, like it's really user friendly. Having all those displays and changes, making all your changes on the screen means that the end user can do all those things. You don't need a laptop, don't need a keyboard.
Talking about the process of actually setting up the boost controller, I'm interested to hear how you deal with sort of boost dropping off at high RPM, which is very common with factory turbocharged engines where the turbo becomes a bit of a choke point at higher RPM. What we would normally do with the ECU is basically have a RPM versus duty cycle map or boost map and bring that duty cycle up to try and hold the boost a little bit flatter. Have you got the functionality to do that with the eBoost 3?
Yep, standard set out of the box, so fit an RPM input into the thing. So it's got inputs for RPM. You can actually, quite a few inputs. You've got switched inputs, you can bring pressure sensors, whatever you like. But yeah, bring RPM into the back of it and then turn on in the software, turn on boost by RPM, and then you can do exactly like you're talking about with an aftermarket ECU. As RPM increases, you can increase or decrease the duty cycle.
How about closed loop versus open loop control? Options for both?
Currently it's all open loop, but we will bring closed loop on board. There is some changes to the setup menu, and we're just going through more the user interface. From a back-end perspective, we're actually able to do the full closed loop boost control. What we are working on is our existing customers, the majority of our existing customers coming from the eBoost 2 world, where it was all open loop. We really want the system to be as user-friendly for them, because we figure the first customers that are going to want to put these eBoost 3s in are going to be the eBoost 2 customers, because it's literally unplug the old one, plug the new one in. It's the same size housing, it's the same connectors in the back. It's physically unplug, replug, and you've got a new modern interface. So we wanted to keep the interface as consistent as possible with those guys. And then over time, I think that we'll definitely introduce a closed loop model. But to do that, it's like, okay, how do we do that? Do we push it into a full closed loop mode, so you change the setting on the software? There's internal dialogue about that, but it's definitely on the way.
I think one of the challenges, and we see this with the aftermarket ECU world, is as soon as you bring in closed loop, it gives a lot of people enough potential to make changes that get them so far out of the ballpark they can't find their way back. So definitely with closed loop, it's a case of the simpler you can make it, the better the results are going to be. Would you agree?
Yeah, that's it. And the other thing with closed loop in particular is a lot of your control variables, your PID settings from the ECU world, are very dependent on the size of the turbo, because ultimately that's what's going to, it's the inertia of the turbo that pushes around how much integral, how much differential you need, because that's how fast the thing spins up. It's how much inertia, physical inertia, that the turbo builds up as it's accelerating. So the speed of acceleration and the weight of what you're accelerating, they're the things that really drive all of your PID settings. So have a totally different set of settings with a small turbo versus a big turbo, regardless of the application. And so we're working on a few ways on how do we set up the front end software so it's as simple as possible. So unlike an ECU where you've got that full laptop screen and a full 3D map where you can make changes to PID settings with the keyboard, how do we display that on a little display without the laptop? So that will come back to things like, well, maybe if we put some settings in the software, tell us a bit about your turbo. Now we can then predefine or get you a lot closer to the PID settings that are going to work really nicely in your application to do exactly what you said, to give the customer a really good starting point so the control system itself is doing a lot less work. Because you're right, you give people too much option, you give them too much control, and they can get so confused that they end up with a worse result. So
always a challenge, I'm sure. CO2 Boost Control as well, for those who want to go drag racing and make crazy power, that's an option?
Yeah, straight out of the box we'll do dual solenoid CO2 control. So that's something that is actually relatively simple to do, but yeah, straight out of the box we can do that. And we will also be bringing in the ability to do the eGate control. Obviously eGate's a big part of our business, so obviously that's a high current controller that we need to do that. So we won't.
There's been a problem for a lot of the aftermarket ECUs, being that I think if my memory serves correct, 20 amp maximum that it'll pull?
Up to, yes. You don't have to run that much current, but basically the speed at which you can move the valve is proportional to how much current you send in there. And so obviously just being pin for pin the same as the eBoost 2, we don't have those high current drivers or even the current available in most of the wiring for the eBoost 3 to run those eGates directly. So we'll have an external driver that will interface with the eBoost 3, and you'll be able to do eGate control with the eBoost 3. That's actually going to be really interesting for the OE market as well, because you've got a lot of OEM vehicles that are running eGates, not ours, but from factory, the Honda, the Volkswagen, those sorts of things that are running eGates from factory, the BMWs, where customers are either taking OEM turbos, small OEM turbos that have electronic wastegates on them, taking them off, putting a bigger turbo on, and we've got guys that are running our electronic straight gates in place of the factory electronic poppet valve internal wastegate. So you're still using the factory ECU to control it, or adding in something like an eBoost to the boost control to one of our electronic straight gates in a factory OE application from a tuning perspective. So there's so many options and layers like that out there in the market that I'm really looking forward to seeing where electronic boost control goes with the eBoost, and giving the end user then the ability to make their changes on the fly, different boost by gear, boost by RPM, different boost groups, boost settings at the touch of a dial. So it's gonna be cool.
No, it sounds like an exciting product, and as we mentioned at the start, not everyone's running an aftermarket ECU, so there is definitely a case study for using this product. If people want to find out more, where are they best to do so?
All the usual places. So obviously the website, turbosmart.com. You can follow us on socials, YouTube, the usual haunts.
Thanks for your time, Matt.
Thanks, mate.